The next topic is pump similarity. And normally HU curve of the pump can be defined from the experiment for the specific impeller diameter and rotation speed. Okay, fit to the speed of the electrical motor, such as the 725, 960, or 1450 RPM. Okay, that is the speed of the motor, and frequency is 50 Hz. But in actual work, maybe is different from the experiment. So for example, if the angular velocity is changed from a different driving engine motor, can change from electrical motor to diesel engine or something like that, and impeller diameter is changed from the design diameter to is not available from the manufacturer, so we have to change some diameter that is smaller. Okay, to solve this problem, we use the affinity law to calculate the volume, capacity, head, or power consumption when the speed and wheel diameter are changed, and S is specific speed is preserved. Okay, this is affinity law for diameter change only. Okay, this means Q is the first order, Q2 is the first order, Q1. Head is power 2, and the brake horsepower is power 3. Okay, for example, if we assume that if D2 is the double of D1, okay, so in this case we expect that B will increase by 2 times, and increase by 4 times, and increase by 8 times for the brake horsepower. Next, for the speed change only, it's the same proportion or same function, that if we try the n speed, n2 is 2 times of n1, so we expect that Q increase double, and head increase 4 times, and power increase 8 times. In case of both diameter and speed change, so D2 is 2 times of D1, and N2 is 2 of the N1. So we expect that the Q is 4 times increase, and for head is 16 times increase, and for the power is 64 times increase compared to the first original diameter and speed. Okay, and this next slide show the example pumping rate of the, assume that if we angular velocity at the 2000 RPM, okay, at the 2000, determine the pump rate head if the rotation speed is changed to 1600. Okay, so if we change the speed to P, and given we know Q1, H1, and brake horsepower 1, Q1 is 1700. Question, what is the Q2? If H1 is 100x 50 180 feet, so what is the H2? And brake horsepower 1 is 84 horsepower. The question is, what is the brake horsepower 2? Okay, based on above the equation, we can say that Q2 and Q1 is the just one first order proportion of the speed, so we got the Q2 is smaller, 1360, and head, and that is the head 2. Head 2 is smaller to from reduced to xt 215 and brake horsepower to reduce to from 84 to 43. Okay. Before we move to classwork, I correct this first. I changed this to homework. And for the classwork, we're going back to the lecture 15 and try to draw the system H curve from the problem in lecture 15.